Hi everyone. Today I come up with an important topic which is from the series of biostatistics, which is standard deviation and coefficient of variation. Standard deviation, coefficient of variation, which comes under measures of dispersion. Standard deviation is the method of absolute measure and the coefficient of variation is the relative measure. Here we see about standard deviation. Standard deviation is the positive square root of the mean squared deviation of the observations from the arithmetic mean. So here is given the formula to calculate standard deviation of ungrouped data, which is as it is in the to find the population standard deviation, the letter sigma represents the standard deviation, which is square root of sum of x minus mu the whole square divided by n, and sample standard deviation denoted by the letter small alphabet s. S equal to square root of sum of x minus x bar the whole square divided by n minus 1. That is one rule, that is if the sample size is less than 30, then we use the denominator n minus 1. Here it is, the n minus 1, that is if sample size less than 30, we use this denominator n minus 1. The sample size is more than 30, the denominator is n, or it is represented by this n. And otherwise, standard deviation, we used to say standard deviation is the square root of variance. And the formula to calculate standard deviation of group data, S equal to standard deviation, which is represented by S equal to square root of sum of f into x minus x bar the whole square divided by n. The relative measure of standard deviation is coefficient of variation. That is, a coefficient of variation is computed as a ratio of the standard deviation of the distribution to the mean of the same distribution. So here comes the equation, that is coefficient of variation equal to standard deviation of the distribution divided by mean of the given distribution. Here Sx represents standard deviation of the distribution, and x bar represents the mean of the given distribution. Here come up with the example, calculate standard deviation of the ungrouped data. So we are supposed to follow these steps. The step 1, compute mean, that is find x bar, that is the first step. You know the equation, x bar equal to sum of x divided by n, that is for the ungrouped data. Then second step, take the deviation of value from the mean, that is x minus x bar. And the third step, the square each deviation, that is once after find x minus x bar of each data, next find x minus x bar whole square, that is take the square of each deviation. And the fourth step, add these square deviation, that is sum of x minus x bar whole square. Then divide the result by number of observation. Here it comes. That is standard deviation equal to square root of sum of x minus x bar the whole square divided by n. This is an example how to do a calculation or how to calculate standard deviation of the ungrouped data. Here it is given the scores, that is the question is incubation period of 10 cases is given below, calculate standard deviation. The scores are 6, 7, 5, 4, 3, 4, 5, 6, 7 and 8. That is the incubation period of the 10 cases is given. The incubation period is given as this, that is 6, 7, 5, 4, 3, 4, 5, 6, 7 and 8. So here it comes, the n is n equal to 10. So the next step we are supposed to find mean of the given data. To find mean, the mean x bar equal to sum of x divided by n. Here the sum of x we get sum equal to 55. So here it comes 55 divided by 10. So the mean of given data is 5.5. This one is supposed to write corresponding to each of the score 5.5, 5.5. Likewise, we are supposed to write, okay, I just come up with that, that is 5.5, 5.5, 5.5. Likewise, write corresponding to each of the score. Then the next step is take the deviation from the score, that is x minus x bar. Here on difference, here it is not modulus, so sign is valid. So 6 minus 5.5, here we get 0.5. 7 minus 5.5, here we get 1.5. 5 minus 5.5, 0.5. 4 minus 5.5, here we get minus 1.5. Then 3 minus 5.5 minus 2.5. 4 minus 5.5 again minus 1.5. 5 minus 5.5, 0.5. Yeah, minus 0.5. 6 minus 5.5, we get 0.5. 7 minus 5.5 gets 1.5. 8 minus 5.5 gets 2.5. The next step is take the square of this deviation, that is x minus x bar the whole square. 0.5, the square is 0.25. 1.5, that is we get 2.25. 0.25 minus 1.5, the square we get, that is 2.25, minus it will comes as the positive, that is 2.5, the square we get 6.25. 1.5, 2.25. 0.5, 0.25. Again 0.25. 1.5, 2.25 and 2.5 we get 6.25. Next step, it is said take the sum of this square, that is sum equal to 22.5. Next we apply this in the equation, that is standard deviation or SD or S equal to square root of sum of x minus x bar the whole square divided by number of observations. Here we got the sum of x minus x bar whole square, we get 22.5 divided by n is 10, that is root of 2.25, we get 1.5. So the standard deviation of given data is SD equal to 1.5. To find the coefficient of variation. The coefficient of variation we can find by the equation. Coefficient of variation is standard deviation divided by mean. So in the given data, the standard deviation was 1.5 and the mean x bar was 5.5. So it apply in the formula coefficient of variation equal to 1.5 divided by 5.5. Here get 0.27. So the coefficient of variation or CV equal to 0.27. Next method, how to calculate standard deviation of group data. To calculate the standard deviation of group data, you should follow these steps. First, take the midpoint of class interval as score. As it is similarly I said in the mean deviation, if it is a data with a class interval, take the midpoint of class interval as the score. Otherwise, if it is a discrete data as well as frequency mean, no need to take the midpoints. Then step 2, compute the mean of the given data, that is x bar. Then take the deviation of value from the mean, that is x minus x bar. As a fourth step, then square each deviation, that is x minus x bar the whole square. As a fifth step, multiply square deviation with the corresponding frequency, which is denoted by f into x minus x bar whole square. Then sixth step, add all these square division, that is sum of f into x minus x bar the whole square. Then seventh step, divide the result by number of observation. Then take the square root, that is number of observation in the sense sum of f into x minus x bar whole square divided by n. Then take the square root of it, which gives the standard deviation. The equation is standard deviation, that is s equal to square root of sum of f into x minus x bar the whole square divided by n. Here we go with an example for the calculation. That is the given data as it is the same data I use here also. That is the class interval, that is 8 to 9, 9 to 10, 10 to 11, 11 to 12, 12 to 13, 13 to 14 and 14 to 15. The corresponding frequencies 8, 14, 21, 25, 15, 10 and 7. Then the following steps comes as it is discussed earlier. Find the score, that is midpoint of the class interval will come as the, that is midpoint come as the score. Then find f into x to get the mean. Then x minus x bar. Then x minus x bar the whole square. And f into x minus x bar the whole square. So here we go with the midpoints come, that is 8 to 9, the midpoint is 8.5, 9 to 10, 9.5, 10 to 11, the midpoint is 10.5, likewise it comes 11.5, 12.5, 13.5 and 14.5. In group data, another thing is n equal to sum of frequency, so take the sum of that. Sum of frequency comes 100, so number of observation, that is number is sample is 100. Then to find the mean, first calculate mean. X bar equal to sum of fx divided by n. Sum of fx, find f into x. Here it comes 68, 133, that is 14 into 9.5. 21 into 10.5, it comes 220.5. 25 into 11.5 comes 287.5. 15 into 12.5 comes 187.5. 10 into 13.5 we get 135. 7 into 14.5 we get the value 101.5. So to get the mean, take the sum of fx. The sum of fx is 1133. So this we apply this data in the formula, that is 1133 divided by 100, so get the mean of 11.33. Then take the deviation of each data, that is x minus, that is 8.5 minus 11.3, we get minus 2.83. 9.5 minus 11.33, here we get minus 1.83. Similarly, 10.5 minus 11.833, here gets minus 0.83. 11.5 minus 11.33, we get 0.17. Likewise, we get the values 1.17, 2.17 and 3.17. The next step is find the x minus x bar. Take the square of each deviation. So here it comes 2.83. The square is 8.008. 1.83, that is 3.34. 0.83, 0.68. 0.17, we get 0.02. 1.17, get the score 1.36. 2.17, get the value 4.70. 3.17, get 10.04. So next is multiply these square deviations with the corresponding frequency. So 8.008 into 8, get the score of 64.06. 3.34 into 14, get the score 46.76. 0.68 into 21, get the score 14.28. 0.02 into 25, we get 0.5, and 1.36 into 15 get 20.4. 4.7 into 10 get 47. 10.04 into 7 gets 70.28. The next step is take the sum of this f into x minus x bar square gets 263.28. So apply these values in the equation, that is standard deviation SD equal to square root of sum of f into x minus x bar the square divided by n. So square root of 263.28 divided by 100, we get the value square root of 2.63. Square root of 2.63 is 1.62. Hence, SD equal to 1.62. So, one thing you're supposed to notice, otherwise in the sense, never take any shortcuts to find the answer. Always follow these steps, then only we get a right answer. So, for this score, what is the coefficient of variation? The formula to find the coefficient of variation is, you know, this CV, that is coefficient of variation equal to standard deviation by mean. Here in this data, standard deviation is 1.62 and mean x bar equal to 11.33. So here comes coefficient of variation equal to 1.62 divided by 11.33. So the answer we get 0.14. So in the given group data, the coefficient of variation equal to 0.14. This is how we are supposed to calculate standard deviation as well as the coefficient of variation. In this section, I hope you understand how to calculate standard deviation of group data as well as ungrouped data. Similarly, coefficient of variation of ungrouped data as well as grouped data. Thank you.